MyProjectBazaar.com. Now we discuss about the product for trigger wave asynchronous cellular logic array for fast binary image processing. Next we see the abstract for the product. Diabetic retinopathy is a disease of commonly found in diabetic patients, which is the major case of blindness and vision defects. It causes the damage of retinal vessels, thus the protein and fat gets leaked out the abnormal blood vessels, resulting in a yellowish integrated deposit termed in executives. This is one of the example of medical image processing levels. These processing levels are mainly based on the binary image based digital image processing systems, because we identify the edge detection process for each and every medical oriented results and the normal results to identify the image variations. To effectively identify the binary image is a digital image processing system. Edge detection is a significant method in image processing, useful in the field of feature detection and extraction. Edge detection is the highlight of sharp and gradual discontinuity in the pixel intensity. Thus, amount of data to be processed is significantly reduced and irrelevant information is being filtered output. There are several types of operation available for edge detection based on the first and second order derivatives. FPGA are a better platform for real-time algorithm and application-specific hardware with consequently greater performance than the programmable DSP. The requirement of process image in real time leads these implementations is the hardware level. It provides a parallelism and thus significantly reduce the processing time. FPGA are highly used to medical image, but the drawback of that the high level language is used for coding. Xilinx system generator is a model of based on the DSP design tools from Xilinx that enables a Simulink design environment, hence makes it easy to handle the respect of other softwares for FPGA design. The objective of this lead to be use the Xilinx system generator process. Xilinx system generator process mainly the identify the image on pixel to pixel basics, thus resulting to modification of pixel neighborhoods allowing the transformations of the whole of partial images. Xilinx system generator provides the interface based on the extensive set of optimized Xilinx and optimized DSP building blocks. It includes slightly higher than abstraction level. It uses the MathWorks Simulink, a list of specification Xilinx block set which can be used to create the optimized design of Xilinx FPGAs. Next we see the flow diagram for the product. This product is mainly based on edge detection based on Xilinx system generator architecture. This architecture to combined by MATLAB and Xilinx oriented process. First we connect the two process and to create the Xilinx oriented Simulink blocks, then to develop our edge detection process. First of all, we browse the given input any one of the input image, then to resize the image and to apply the parallel to serial functions. This pre-processing were combined by three processing. This process to be selected for the image integer values one by one, then to apply the Xilinx system generator based Simulink skeleton identification. This identification to identify the image by edge variations level. This edge detection identification based Xilinx block to create the private and various model of edge detection architecture using Xilinx Simulink blocks. Then to apply the image post processing module, then to identify the edge detection values, then to order the reallocate the image matrix form for original image. This image to be processed the output for edge detected output images for given any type of input images, then to apply the system generator function. These generator functions mainly used to convert the Simulink design to required BHDL or Verilog codes. This code to apply the FPGA process. This is the final output results for edge identification image display. Then the system generator to convert the Xilinx design to VHDL code, then to apply the Xilinx software, then to calculate the Simulink results and synthesis results for overall edge detection process, then to calculate the RTL technological diagram for required edge detection architecture in FPGA process, then to identify the hardware based performance analysis. This is the timing based results for overall FPGA architecture. Then to see the final output for the product. These are the final design for overall Simulink based Xilinx process. This process to identify the overall edge detection for given selected input image process. These are the final Simulink model design based on the Xilinx oriented block. Then to run the process and to already selected the one of the image part to apply the our process. These are the various output results for edge detection calculations based on the binary image processing. These processing full and full the binary based calculations. Each representation, these are the given input image. This is the prefit and so forth and various edge detection. This edge detection process to identify the future values for overall informations. This is the variation for image minute variation based on the bitwise processing analysis. This process to identify the each and every variation images to identify the effectively, because this is the binary image processing system. This processing to develop the bitwise processing to remove the overall noise performance level for given input images. Then to convert the codings and to create the Xilinx oriented blocks. This block to display the coding for our overall required blocks designs. This block designs to convert the package and to perform the overall performance analysis results. This is our converted coding work for required our overall Xilinx oriented Simulink designs. This is our converter process, and to calculate the RTL diagram for overall architecture process. The RTL diagram to represents the overall functions for architecture's level. This is our the clocking sequence for each and every architecture process. This is the edge detection block for overall architecture results. This is our the RTL diagram for edge detection architecture process. This is our required VHDL work for Simulink designs. Then the technology diagram. The technology diagram to represent the buffer and logical gate structures for overall architecture process. Then to calculate the design summary process. The synthesis report to generate the what are the timing presented for edge detection overall work. This is our the architecture results for edge detection process, and this is the timing results for edge detection process. These are the various timing results for different edge detection architecture process. Then to calculate the clocking frequency, these are the speed allocations for, these are the latency timing calculations for our required edge detection process in FPGA architecture.